I'm going to be covering the prisoner's dilemma, science simulation in this particular video. I'm at SHS Galbraith in the science simulation section. I'm going to go down to the prisoner's dilemma. So the first thing for this is to actually grab the code. So you can either grab the code down below here, there's a lot of it, copy all that, or you can go to the Google Doc version to get it. I'm going to do that. So I'm going to go ahead and select all and copy that. And then if you have the processing app on your computer or on your iPad or whatever, that's probably the best place to use it and paste the code in there. Or you can go to this Open Processing, which is a website. I'm going to go to here just because that's more universal. So first thing, delete whatever this is and paste in the code that we have. So now all the code is here. Notice this is the code tab and this is the run tab. Now there's one more step we have to do over here under the settings. This website has two different languages. We want to make sure we're using the processing language. Otherwise it won't work. So now if I run this, we have the prisoner's dilemma that starts up. We have a graph of the various players. The little circles that have red around them were people that were doping. And then you notice that there were random people that were tested. This guy happened to be doping and was tested, so he got caught. And then it has a little race that they're going through. The various places have different amounts of score that are assigned to them, and those are things that you can change within the simulation. But basically, if you continue doing this, you end up accumulating an overall total from the various races. And each of the races, there are different chances that people are going to dope and that they're going to get tested. If I want to change anything in here, up at the very top is right down here where I can actually change whether or not the different players were going to dope each round. So you get to choose for the first player every single round if you want to. And you basically say whether you're going to dope or not every time. The other players are basically computer controlled, and so they have different strategies that they can do. We programmed in 4, so you never dope, you randomly do it based on a chance here, this random doping chance. You just do whatever player 1 did the previous time, or you always dope. And the goal with these things is to try and see which kind of strategy is the best one where you maximize your score. There's also the chance for when they will check for doping and how much they're going to fine you in points, and then what your various awards are going to be. There's also different ranges where you kind of test to see if you get a speed up or not. So this is how much of a range from the top and the bottom that people's speed is going to vary by. And this is how much of an advantage the doping gives players. So you can alter all of these as well and see how much of an effect doping has upon it. And then this is just what is the delay between your race and your graph. So if I want to change a few of these things, let's say that I want to, instead of using never doping's thing here, maybe I want to change this to always. So make sure I match that. And if I rerun it, now that particular one is always going to. So notice he's got the red circle around him. Hopefully that gives you an idea of how to use the prisoner's dilemma.